There we go. Is that coming through okay? Awesome. All right, so this was developed for part of my wider team. As part of my role, I'm the math teaching and learning leader at Ormiston Primary for phase 2. So we have over 80 teachers in our school, 1,400-ish children at the moment, but our role's currently fluctuating constantly. And my team is 4 teachers teaching in an MLE space with currently 89 students. So there's a lot of moving and working parts. Not just that though, in our space, we mostly have first and second generation migrants to New Zealand. So all of our learners speak at least, well, 75% of our learners speak 1 or more languages in addition to English. And for most of them, it's 2 or 3 different languages in addition to English. So they're coming from a very different perspective to that of most schools around New Zealand. So who am I? This is my introduction slide that I give to my children at the beginning of the year. So I've got 2 children. Annabella's 10 and Toby is 2. Annabella's dyslexic. So that's one of the reasons that I really advocate for math to be about math and not about literacy. My husband is here. This is him dressed up in a kilt for our wedding to honour my Scottish heritage. My family actually arrived in New Zealand, Aotearoa, by boat in 1814. My ancestors were originally from Scotland, and I love the fun fact, the kids always love it, that the national animal of Scotland is a unicorn. So as a teacher, I've worked at Ormiston Primary School my entire teaching career. I spent 4 years as a new entrant teacher before moving to year 5 and 6 in 2024. I'm a lifelong lover of maths, and I've already gone over my brief introduction there. So let's get into it. Fractions on a number line. While we did tons of work in fractions in the past, this fractions on a number line thing was something that was new to our team with the refresh curriculum. And so we really wanted to see how we could do it justice. And what we found out was that our children did not have the deep understanding of fractions that we thought they did, because as soon as we put them in a different context, they had no clue what we were talking about. So this, what I'm working with at the moment, aligns to phase 2, particularly because that's the area I work in. The stuff in red is specific to year 4, and then year 5 and 6 covers the rest of it. So for fractions with related denominators of 2, 4, 8, 3, 6, 5, 10, 12, or 100, compare and order fractions and identify when 2 fractions are equivalent. Also find a fraction of a whole number where the answer is a whole number, is the space we're working in for curriculum alignment. Resources that we used was a long strip of paper for a number line, pens to record, blocks, cubes, or counters of the same size, and Cuisenaire rods. And I don't know if I've said that correctly. Specifically, we used this format for halves, quarters, and eighths, which are related fractions, and halves and fifths. I'm going to skip over the misconceptions because we'll get to that a little bit later. So this was my first iteration of the lesson using the Cuisenaire rods in particular. The learners who are helping me achieved 2P and 2A at their most recent ESTL before this lesson. And I just want to show you what comes up with them. So we think that they're like, yeah, absolutely, we know a half. The actual inner workings of it was not where I thought they would be.
Hello and welcome to our math lesson today. Thank you for volunteering to help me. So we are going to make a fraction number line today by comparing our different fractions. Now on our number line, we know that fractions are part of a whole. Okay, so at the start of our number line, what are we going to have?
A 0.
A 0, that's right. 0. Actually, I'm going to have one of you write that. Just over here. Start your number line, you're going to write the 0. Amazing, perfect. And at the end of our number line, what are we going to have? 1. And we're working in the middle of the 0 and the 1, parts of a whole. The specific fractions we're going to be working with today are halves, quarters, and eighths. Okay. In front of you, you've got a packet of objects. I'd like you to empty them out onto the table. What do you notice about them?
They're
They're colourful.
and then they're like some are short and like some are long.
Some are
You mean
short and
different
some are long.
sizes?
There are different sizes. So if we were to line up this, we're going to call our one hole here. We're going to line up the other pieces in colour order. What are we noticing?
That those two are different from all of those rest.
So if we keep lining these ones up, like this end on end, what do we notice?
They're all going to be the same size.
They're all going to come to the
Except for-
same size. And try with the ones as well.
I'm just going to pause it there because I made a note down the bottom of those slides. I shouldn't have used the terminology ones when referring to the white blocks, but sometimes in teaching we just use the wrong words.
Yep. Okay. So it's fantastic. So this is our one hole. Okay. And if we were to break it into 2 pieces, what would we call those 2 pieces?
One half.
Yeah, we'd call them halves, wouldn't we? So where does half sit on our number line? Do we know that already?
Yep, over there.
Half should sit at the 0. So if I was to break this number line in half, where would it go? What am I doing with a half? I'm splitting it into 2 equal parts. Okay, so one way for us to split our number line into 2 equal parts is to fold it. Can someone help me with this one over here? Amazingly helpful. And now we can see that this side of the paper is the same size as this side of the paper. So half actually belongs here, right in the middle. That is 1/2. I'm going to ask you now, looking at your objects, and take these ones away. If these are halves and they're split into 2 even pieces, what are these ones? Quarters. They're split into 4 even pieces, aren't they? So can you tell me, is 1/2 smaller or bigger than 1/4? Let's have a look at your resources. Go to the 1/4, 1/4, and 1/2. Can you compare the sizes for me? Which one's smaller?
The
1/4. So where is the 1/4 going to go on our number line? Yeah, it's probably going to go closer to the 0, isn't it? Well done. Okay. What about 3/4? Is that smaller or larger than 1/2?
it's bigger.
Yeah, and try it with the resources. Look how we're lining them up end to end. Okay, so what does that mean? Where is 3/4 going to belong? Yeah, slightly further up our number line. Excellent. What about 2/4? What can you tell me about those?
They're the same size, so they should go next to the
They're the same size as what?
same size as this
Yeah, the same size as half. So it's what we call an equivalent fraction. that is going to come right underneath there because 2/4 is the same size as 1/2. It's the same distance away from 0 and the same distance away from 1 as our 1/2 is. Okay. What about this one? What is 4/4?
They're both, we should go back to 1.
You reckon it should go back to 1? Yeah, why are you thinking that?
They both would equal 1.
We take out 4/4 and we compare it to our 1/2. What do we find?
That they're both the same.
That they're both the same. So where are the 4/4 going to go?
Here? No.
There, it's equivalent to 1. If we have all 4 of our quarters, we have our 1/2. Fantastic.
Ready. And I paused that there and stopped that lesson. We can see how I could have gone on with 8s as well, comparing them to the different sizes that we already had on the number line. I've also noted in here that I'm not really worried about the accurate placement of our 1/4 on the number line at the moment. It's more comparing them to what we already know. That came later on in our unit. So the Cuisenaire rods are great for a limited set, particularly for our Year 4 learners where we are comparing fractions to comparative fractions, like our halves, quarters, and eighths all work together quite well, but they're limited. So I couldn't use a different set of Cuisenaire rods to compare our fifths to our eighths, for example. So the way I got around this is our next session.
Hello.
Oops. Which was comparing fractions using objects. So this is where they had to get a fraction of a set and use it to compare it to a different fraction of the same set. These kids were really great. I had pulled them out of tidy up time at the end of the day to do this lesson, and you can still see that they're super engaged with the content.
Okay, so we're working on our number line together. Our fraction number line. This time we're going to use objects to compare the sizes of different fractions. Okay. I'm going to ask you to use 16 objects. So can we take out 16 objects?
Doesn't matter about the color.
It doesn't matter about the color.
We need to get like 16, right?
You can get 16 objects each. Okay, could you double check you've all got 16 objects for me? Excellent. Okay. While I'm getting my 16 objects, we're working in eighths. So how many equal groups do we need?
8.
8 equal groups. Can you split your objects up into 8 equal groups, please? Got some really interesting groupings going on here. So if I wanted you to split things into 8 equal groups, it's going to be 1, 2, 3, 4, 5, 6, 7, 8 groups. And then 1, 2, 3, 4, 5, 6, 7, 8 groups. How many groups have you got over there?
Oh.
You got 4 groups, right? Excellent. I love how you made that realization. We need 8 equal groups. Fantastic, thank you, team. Now, each of these groups is equal to 1/8. Okay, I'm going to ask you to take out 3/8. 3/8 is what we're going to be working with at the moment. So that would be 1, 2, 3 groups of your 8ths. Fantastic. While you're doing that, I am going to split my counters into quarters. So that is 4 even groups. And I am going to take out 2 quarters. Can you tell me, is your 3/8 bigger or smaller than my 2 quarters?
Smaller.
Your 3/8 is smaller than my 2 quarters. So where is that going to belong on our number line? Let's put it in. Your 3/8 is smaller than my 2 quarters. So where is it going to belong? That's right. Thank you so much, team.
And that was actually our end of day karakia that you heard in the background. So that's why I wrapped that up really quickly instead of comparing it also to the 1 quarter to see where it would fit in the middle. So that's the basic premise. I'd love to know what misconceptions you guys saw cropping up with my learners in those 2 videos, and these kids are year 5 and 6. And I don't think I can actually see the chat. Oh no, here we go. Okay. So one of the misconceptions that I was unprepared for when I first ran this lesson was how many of my learners thought that 1/2 was such a small number as a fraction that it belonged next to 0. And that's kind of come up every time I've done this with a small group.
Okay, so we're working on our number line.
Sorry, trying to pop on along and I keep pressing the play button. Another misconception that I thought was really interesting with this group is they could tell me that they wanted 8 even groups without 8s. They said that straight away. And yet as soon as they came to separating out the groups, we saw quarters, we saw halves, but they couldn't show me what 8 equal groups was. Now, since I've recorded these sessions, I've been introduced to fraction frames and fraction windows. And I'm going to be using those in future with these groups so we can show them what the groups look like first and then pop our objects in them. So I think that'd be really effective for this group. But I actually started, there we go. I actually started these lessons with an independent task that looked like this, because I was so confident that my year 5 and 6 learners would absolutely be able to split things up into sets, that I gave them an independent task worksheet. There was 8 separate tasks. I got them to go away and figure out if 3/10 was bigger or smaller than 3/5, for example. And then we were all going to come back together. We're going to share the knowledge that we got, and we were going to put our fractions up on the number line. I was so confident. What happened instead is that even my learners who were achieving at stage 5 of the curriculum had no clue what I meant by a fraction of a set. So we had to step it right back, whole group work, less independent work, and figure out where those gaps in knowledge came from. Because these kids could do the long division. They could figure out for me that 3/10 was a lot smaller than 3/5, just using their knowledge of fractions and decimals. But what they couldn't do was then take 10 objects and show me what 3/10 looked like physically. And that's where we went to from there. What was I going to say here? Oh, I did painstakingly go through these worksheets and blank out the sideways slash on the fractions and make sure that they were all represented one underneath each other, because I can't figure out how to do that with my computer yet. So that was a lot of time and effort. But I think that's really important too, because our learners need to see that the denominator is on the bottom and not to the side, particularly when they're first learning fractions. So otherwise it's really easy. I mentioned in the beginning, my daughter's dyslexic. Super, super easy for them to just flip the numbers around and not know where the denominator or the numerator is. Okay, I'm gonna skip back through. Sorry, I've been a little bit messy with my skipping today. To our common misconceptions that we didn't do at the beginning. So misconception 1 didn't come up with this group, but the bigger denominator means that the fraction itself is bigger. Our second most common misconception is that fractions are only parts of one whole. So you saw in what I was doing was only 0 to 1, but my extension on from that is when we'd be doing, what does 5/4 look like and where would that belong on the number line? So we'd extend it out. It was just an initial lesson with these learners. And where fractions are placed linearly without considering equidistant placing between half and quarter. Obviously, I was feeling very fancy when I wrote that one, so I apologize. And that didn't come out with what we were doing because I wasn't worried about where they were placing them as long as they were placing them in relation to each other. Explicit teaching pedagogy that came up in that was modeling and verbalizing out loud. I can see that 1/2 is halfway between 0 and 1. So where would the 1/4 go? Direct, clear instructions for the learners. We started with reviewing their knowledge of fractions and then correcting as they went along. And because they had manipulatives in front of them, that makes it accessible for everybody. And that was a confusing point I've got jumbled up in my head that I wanted to get to. As I said at the beginning of the session, 75% of our learners speak at least one other language. In my class of 89, we have 20 that are currently on ministry funding for English learning language progressions. And for those learners, while the math is the same in their home language as it is here, when it is written problems that they have to decode themselves into their home language, understand it in their home language, and then produce the math, that is a lot less accessible for them. But having things in front of them, the Cuisenaire rods, counters, unifix cubes, that they can physically manipulate to see the math, makes it accessible to everybody in my classroom. And some of these I got to, and some of them I didn't. Like, can you explain your thinking to your partner? Would have been great if I'd had a slightly longer session. But these are questions that would come up with this lesson as you're doing it as a whole. Is there any questions, feedback from that first part?
Kia ora, team. If you do have questions, just pop them through into the chat so we can all see them. Otherwise, feel free to just unmute yourself and throw the question out there. Otherwise, Dannielle might feel like she's talking to herself. So,
sorry, can I ask a quick question? Is my mic working?
Yes, we can hear you.
You know that activity you did where it had independent task number 1, and you said you gave them out to different groups to work on. Was the thing that changed on each one the number of objects that they had to use?
It
Or
was
the fractions that changed?
It was the fractions that changed, and with it was the number of objects. So with my group that I had with me, I specifically was working with just quarters and halves so that they could compare that, because that was the level I wanted them to get to. And then randomly assigned to the rest of the habitat was anything from halves to quarters to fifths to thirds to eighths to see. And then like we're working with factors and multiples as well, was something that came up in that conversation. So the reason I chose that many objects was because it's a multiple of the two fractions that we were using, or the two fractions that we were using. Denominators were factors of what we were using. So some of our kids were using 60 objects in order to compare two different fractions, for example. Does that make sense?
Awesome, thank you.
All right, I'll continue on. So related things that we did around this unit that my kids found a lot of fun was as I said, discuss and defend about where does 5 quarters, see, I've done it with the writing there, I apologize. That should say, where does 5 quarters fit on the number line? And you can see it down here that it's properly written. It's just my bad writing on the slide. So then having to discuss that fractions go further than just 0 to 1. They're equivalent to X, Y, Z afterwards. That was a really interesting discussion. The inequality challenge was something that my learners are still asking to do. And I thought it would be a 5-minute just to get them to know where inequalities are, because of course those come into the curriculum now at year 6. So the goal is to quickly and correctly form the inequality symbol with your arms to show the correct relationship with two numbers. You split into groups of 4 and each pair of players faces each other, forming a diamond shape like I've got over here in the corner. The two places facing each other say tahirua toru, and then they quickly hold up a number of fingers anywhere between 0 and 10. And the players in between them look at both numbers and then race to form the correct inequality symbol. The learners then switch places with their other partners, becoming the leads. When I say that my children played this for 20 minutes straight and were very upset when it was time to move on, I'm not exaggerating. They all loved it, even though there wasn't a super competitive edge. We're not assigning points. And it really did help with their things, because they got to make those big symbols and figure out what they actually meant. And the other one I've got here, I think, is fractions buzz. And we should be mostly familiar with that, how to play buzz. It's just adding in fractions, making sure that they can count in fractions, saying buzz when something is equivalent to 1. I haven't added in the challenge yet for my learners, because we're not quite there along our fractions journey, where they get to say zap instead for any fraction that's equivalent to 1/2. But of course you can edit and modify the rules as you go. All right, I have gotten to the end of my slides. I am aware that I talked very fast, so it's probably the reason. But yes, we're free and open for any questions or feedback, things that you'd change as well, because I'm very open to that.
Alrighty ho. Wonderful world of fractions at a glance. It always seems a challenge when we get kids into year 9 at our high school, that kids can do a lot of the written work, but visually they still can't represent what a fraction actually looks like, which is kind of concerning. So it's great to see some work being done to sort of mend that, if you want to call that. Feel free to open up your microphones and chuck through some questions, or put some questions into the chat. Yeah.
And thanks for coming on your Saturday morning.
Right. You are right, Dannielle. It is a hard task to get a huge audience to, on Saturday morning. But is there any final sort of remarks or things you'd like to say, especially for those that will come back and watch this in their own time? Is there any thoughts, anything that you could provide, anything additional that could be useful?
Ooh. I might just take back to the real beginning when we're talking about, or when you mentioned that our high schools are moving from modern learning environments back to, their standard classrooms. And there's been a lot in the media recently about how MLE classrooms just don't work. I think it really depends on how you run them. So my team works so brilliantly together. We're able to meet needs as ad hoc as we go. And we don't have to rely on, although we have some brilliant teacher aides and learning assistants in our school, we don't have to rely on them. We can split our classroom, and we often do for math. So we take 3 of our learning coaches, take a third of the classroom each. And then one of us is running either a permanent ongoing intervention, like Spring into Math, or we're running a ad hoc intervention where we've seen a need across our habitat with learners that haven't got a concept, and we can address that there and then without really sacrificing any of the other learning that's going on. I quite like working in an MLE environment, although I'm sure a single cell might be a little bit quieter.
But I think what came out of it was there seems to be a lot more distractions once they get into their teenage years.
Mm-hmm.
And so the boys at Shirley Boys, where this article was based on, just saying that 3 walls are glass or the room's quite open and it's quite noisy, just wasn't giving them enough time to be able to sit and think. I think it's just a symptom of the teenage brain, unfortunately.
Oh, absolutely. And like different things work for different teachers in different schools too.
Yeah, absolutely. You are right there. Every school has has different needs for their students. Now, Janine's made a comment around getting teachers to focus on manipulative over and above slideshows and books is sort of one of the key sort of things, especially for kids this age.
Mm-hmm.
Do you have any sort of thoughts along those lines?
1000% agree, and that is something that we, in my role, I'm focusing on in our school, because you notice junior teachers tend to do it really naturally because they have to. Your kids are not going to focus on a slideshow because that's just not where they're at. So you have to have the manipulatives out for them. But it seems to be when we get to that year 4, year 5, year 6 stage, sometimes even year 3, the teachers seem to drop the manipulatives because the children are seen as able to do the book work. But that's a huge drive that I've got currently at my school, and we're making changes there to make sure that we have got the resources, the manipulatives, the visual math in front of them, so they know what the mental stuff actually means. And so my goal for last term was to make sure that I had manipulatives for every single math lesson that we ran. And it was tough, but it was really good. And the year 5 and 6s do respond really well to being able to move things around in front of them.
It is something that we unfortunately don't see a lot of at high school in our space. Although there is a bunch of really, really cool resources online. There's some really cool teachers around the world that still persist with the manipulatives right through into high school. Yeah, it's just a shame that there is a disconnect at some point with that. So I don't know what the answer is there. It's almost like teenagers this day are getting brainwashed by PowerPoint, and most of us are fairly guilty of that to some degree.
You can see from my slideshow that I quite like a pretty PowerPoint, so I'm not saying they don't have any place.
No, but I certainly know firsthand what that experience is like when you've got kids 5 periods a day And that seems to be the default that teachers in high school sort of go to now, for whatever reason. Yeah, I can see Robin's busy there in the background. Does anyone else have anything else that they'd like to say? Otherwise, we will sort of close the session and send you all on your merry way.
I agree with you, Janine, about the confidence of using the materials as well. That's something that we've come up against. I was told in a math session yesterday that Taharangi has now got videos on how to use resources and manipulatives. And that's something that we're going to be looking at as a school. And those were designed by Spring Into Math, but the ministry's got support to use them, permission to use them on the website. So I'm looking forward to diving into those this weekend too.
Okay, we are finished a little bit earlier than we had forecast, but we would like to thank you for your participation. Dannielle, thank you for your mahi. If anyone has got any further questions for Dannielle, you can reach out. Her contact details will be provided once the information goes through to Jared, who will get the website updated with all the resources in due time. Thank you, Dannielle. I'm not sure if Robin wants to jump in and say anything, or yeah. Right, she's got some.
Here I am. I'm unmuted, talking to the talking to the wall. So just wait. Yeah, thank you, Dannielle. It's nice to see physical manipulatives, not always digital manipulatives. You know, there are some very cool digital manipulatives for fractions, which we can drop into, you know, that I've seen that I quite like using with all levels, but to actually have them hands-on, you know, moving, cutting, feeling, measuring, I think that's just so awesome. So thank you everyone for popping in here this morning. Just to let you know that things that are still there that you might be interested in, the NZAMP conference is in Dunedin, so if you want to go to the Deep South or are from the Deep South, that'll be in the first week of the July holidays, and there'll be sessions, you know, from new entrants through to, you know, year 13 there. Maths Week is still on our radar, and it'll be back in 2025. The Auckland teachers, if you've got students, if you're a 7-8 teacher or a 9-10 teacher, then Mathics, we have that open to everybody in those those year levels. There is nothing, I don't know, the junior South Auckland Maths group, they run other sessions for younger students, but we only do the 7 and 8, 9 and 10. And then Jared will be organising another AMA online for you in August. So pencil in the 23rd and we might see you then. I suppose the last thing is that we have been recording this, and Jared will email you with information once those are all ready, and you'll be able to revisit this or share it with your colleagues, and then encourage them to come along next time. Otherwise, ka kite.